Today, we're taking a closer look at what's behind QIC Assess, and more importantly, why it's become such a trusted tool for field ops teams worldwide. Let's start with a quick stat check. Since 1994, QIC Assess has been deployed in over 400 projects across 14 countries, supporting operators in arid regions, Arctic zones, offshore systems, and complex multi-source gathering networks. Not because it's flashy, not because it's easy, but because it works, and it's grounded in real physics, field data, and decades of engineering integrity experience. In fact, here's something you might not know. The technical foundation behind NACE's ICDA standards for both wet gas and so-called normally dry gas pipelines was drawn directly from QIC Assess methodologies. That's right. The entire approach to internal corrosion direct assessment, ICDA, adopted by NACE in 2004, it's a formalization, albeit simplified, of the same three-phase modeling, water hold-up profiling, and corrosion forecasting that QIC Assess has been using since the early 90s. That's a legacy built on experience. And now, we've made it accessible to field teams who don't need a dissertation. They need guidance they can act on. So let's talk about how QIC Assess helps you do that. Unlike most time-based programs, QIC Assess doesn't treat all pipelines the same, because pipelines aren't the same. Not in flow, not in terrain, not in tie-in configuration, and certainly not in their corrosion risk profile. That's why QIC Assess uses mechanistic three-phase flow modeling, tools like PipeSim and OLGA-S, to simulate how oil, gas, and water actually behave in your line. Think of it like 3 lanes of traffic, each phase moving at its own speed. Water doesn't always keep up, and when it lags behind, pools or traps in low points, that's where corrosion takes hold. And from that analysis, we generate a CMP-IC, a Corrosion Management Plan for internal corrosion. Tailor-made, field-aligned, risk-appropriate, fully aligned with audit frameworks like CSA Z662 and NACE standards. CMP-ICs deliver mitigation plans that are not only technically sound, but also regulatory ready. We're not just recommending inhibitor every 90 days. We're specifying where to inject MEG, when to adjust batch intervals, how to match pigging schedules with actual water trap formation, and why certain segments need vapor phase amine instead of standard liquid inhibitors. It's precision-based mitigation, built from the inside out. And this isn't limited to just one sector. QIC Assess is actively supporting gathering systems with intermittent flow and upstream contaminant ingress such as debris and oxygen, where flow shutdowns or inconsistent tie-in contributions can rapidly shift corrosion conditions. It supports midstream networks with elevation-induced water slugs, where terrain effects drive localized corrosion risk and mitigation schedules must adapt accordingly. It's used in non-conforming dry gas lines that aren't dry during upset conditions, capturing transient wet gas exposures that typical programs miss. It supports crude oil pipelines with batch delivery tie-ins and variable separation performance, where tie-in cycling changes flow chemistry, water wetting, and oxygen exposure. And it addresses liquid product pipelines, where start-stop behavior complicates traditional inhibitor programs, requiring corrosion plans that evolve with actual operating schedules and not just design assumptions. And here's what really sets it apart. QIC Assess doesn't just identify where corrosion is likely, it tells you what to do about it. That's what field teams have been asking for, and that's what CMP-ICs deliver. So if you're ready to manage corrosion with the same precision you'd use to manage flow rates, pressures, and production volumes, QIC Assess is here. Legacy tested, field proven, audit ready. Let's bring some clarity to internal corrosion and some confidence back to the field. Thanks for listening. See you next time. You can learn more and download sample CMP-ICs at trustedpipelineadvisor.com.